Hello once again, geometry students. This is Mr. Butterbaugh with you. Today's notes are titled 6.3 Triangle Inequalities. Alright, and one thing before we get started, I do apologize. Triangle inequalities is a rather large topic. So if there's one topic that I really need you to focus on, and one video I really need you to focus on, it's going to be this one right here. Stay with me. There's a lot to write down, but I know you guys can do it. You've been doing great so far. Alright, first part of these notes, we're going to talk about the triangle angle side theorem. So talking about the sides of a triangle compared to the angles of the triangle, there's a couple of relationships that take place. The first one we can talk about is the fact that the largest angle of any triangle is opposite the largest side. We'll see that in a second. It's also true that the middle angle, so the middle angle is opposite the middle side. Okay, and then these little symbols here just mean the same thing as above. Guess what? The smallest side, or the smallest angle, is what? What do you think? Opposite the smallest side. That's right. So to illustrate this, we have the SML technique. SML stands for small, medium, and large. And so on a triangle, there's always going to be a small, medium, large side of this. So the directions say to list the angles of the triangle from shortest to longest. Notice it says shortest to longest. It's going to be very important. We see that. Sometimes it'll say longest to shortest. Sometimes it'll also talk about the sides instead of the angles. Make sure you read the directions. All right, so I can find my smallest angle. So that's what I find. My smallest angle is going to be opposite my smallest side. Well, here's my smallest side of this triangle, since the lengths are 14, 22, and 28. Across from the 14 side is this angle right there. So this is going to be the smallest angle. All right, and then across from the 22 side, that's the medium side. Across from that over here is going to be my medium angle. And then across from the largest side, 28, across over there is going to be my largest side. So there it is, SML, small, medium, large. So if I'm putting these angles in order from shortest to longest, angle C would be the shortest, and then angle B would be the middle, and then angle A would be the largest. Or I could write this as angle C is going to be less than angle B, which is going to be less than angle A. And those are less than signs, not the angle symbols. I know they kind of look the same, but in talking about this, C is the smallest, B is the middle, and then A would be the largest angle. And then that brings me to the actual triangle inequality theorem. Here's the title of the lesson. Here's the main part of these notes. Triangle inequality theorem states that, write this down, the two shortest sides of any triangle must add up to be greater than the third side. So if I have three sides of a triangle given to me, or if it talks about three sides of any possible triangle, the two smallest sides given must be greater than the third side. And we're going to actually explore this more in class. It'll be a fun activity to actually drive this home and see why that is true. But for just example, there it is to you. And for example, that gives us, can a triangle be formed with the following side lengths of 11, 15, and 12? Well, my two shortest sides, 11 and 12, if I add those together, 11 plus 12 is equal to 23. All right, and 23 is in fact greater than 15, so yes, this can be a triangle. All right, another example, if I have side lengths of 10, 3, and 7, my two shortest ones are 3 and 7. If you take 7 and 3, add it together, it gets 10. Well, ask yourself, is 10 greater than the third side, which would be 10? No, it's not. It's equal to, so it's not bigger than it, so it's no. Not a triangle. Not possible to draw a triangle with those three lengths. To illustrate this last one here, example B, let's bring it over here and let me draw it out. Okay, we're going to have one side length with a side length of 10. Another side length will be side length of 7. And then I've got a third side length that say it's going to be possible 3. Okay? If that's the case, those three side lengths, let's see if they'll actually come down to form a triangle. I'm going to kind of put an exploration into effect. All right, that's 7. If it kind of lays down here, just lay it down flat. That's going to be 7 right there. All right, and then if I've got the 3, it comes to kind of lay down. Again, I'm following that side length down 3. If this is 3, what happens? Well, the 3 and the 7 together actually equal 10. So we're not going to make a triangle. It won't be a two-dimensional triangle. It's actually just going to be a one-dimensional straight line there. It's not going to form what a triangle would be. So we can see if 7 and 3, if it's less than those two, for example, 2 and 7, obviously 2 and 7 would be less than the 10 there. So we go back to our triangle inequality theorem. The two shortest sides must add up to be greater than the third side. Okay, if these are bigger, 4 and 7, well, 4 and 7 will actually come down and form a triangle. All right, and the last topic to cover here with triangle inequalities is finding the range for the third side of any triangle. So example 3, two sides of a triangle are given to us. So if they ever give us two sides, and for this example they give us 5 and 12, they want us to find the range for possibilities of the third side. Well, what's possibilities that the third side could be? It's not just one number, there's multiple numbers it could be, but what's the whole entire range? So let me try and talk about this a little bit with an illustration here. If I draw my side length, let's say this one's 5, and then I've got a third one that's going to be side 12. I'm sorry, second one 12, and then this third side here is going to be my side x. So what could x be? Well, if I kind of like my last time lay it out straight, what would happen if this is a straight line here? Just kind of bend the 5 out here and make it a straight line. So if the 5 is right here, and then the 12 goes right there, and it's right there connected. Okay, then my third side, if it's a straight line, the third side would also be a straight line, so this wouldn't really happen. Well, the 5 and the 12 together gets 17. So I notice that my third side, I call it x, has to be less than the 17 right there. So x has to be less than 17 in order for it to actually work. If it's 16 or something like that, then the 5 could be stretched up a little bit or brought up here, and then my third side would work right there. In another case, if I kind of overlap the two sides, so my 5 in my original example here, if I bring the 5 over here and lay it on top, so 5 right there, and then the 12 would be like on the same place right there. There's 12. Okay, then this third side is going to have to go from one corner to the next here. So from right here, the 5 to the corner of there. So if I subtract now, 12 minus 5 gets me 7. And so my third side has to be greater than the 7 that's given to me right there. It could be 8, or it could be 9, or it could be half of that, 8.5, 9.5, something like that, in order for that 5 to like push it out a little bit here, and then for the third side to be given to you right there. If it is 7, it's going to lay flat. Greater than 7 is going to kind of push that 5 side out. Hope that makes sense. So if I want to actually find the range, it's got to be a culmination of both of these things, the 7 and the 17. So it's got to be at least 7, so x has to be greater than 7, but then x also has to be less than 17. So here's how I write my final answer here. My x has to be greater than 7, but less than 17 to actually create a triangle. And again, we'll call and illustrate this a couple more times tomorrow. So to find those things, if you want to talk about it that way, to be able to find the possibilities for the third side, if you want to add the two given sides together and then subtract the two given sides, the third side must be between the two values. Okay, so let's say it again, or let's do another quick example. If I have two side lengths, let's say they are going to be 4 and let's make it simple, 6. Okay, what are the possibilities for this third side? We'll take my 6 and my 4 and subtract them. So 6 minus 4 is 2, and then add them. 6 plus 4 gets me 10. So my third side has to be between 2 and 10 for the reason above there. So 2 has to be less than the third side x, but then the third side x has to be less than 10, and so there would be my answer. Quite simple, just to add and subtract, but the reason behind it is given to you above. All right, like I said, triangle inequalities kind of encompasses a bunch of things. Hopefully that makes sense in your notes, and you can bring it to class and we can work on it together.